Good afternoon, everyone. Today, I would like to talk about the 2003 Nobel Prize in Physics. I chose this topic because it shows how matter can behave in extraordinary ways under extreme conditions. The prize was awarded for pioneering contributions to the theory of superconductors and superfluids. At first, this may sound complex, but the main idea is very interesting. Normally, when electricity flows through a material, there is resistance. This resistance causes energy to be lost as heat. However, under very low temperatures, some materials behave differently. In a state called superconductivity, electrical resistance becomes zero. This means that electricity can flow without any loss of energy. In theory, once a current starts flowing, it can continue forever without stopping. There is also a similar phenomenon called superfluidity. In this state, a liquid can flow without any friction. It can move through tiny spaces and even climb up the walls of a container. These behaviors seem almost impossible in our everyday experience. The prize recognized theoretical work that explained how many particles can act together in ordered quantum states. These contributions became central to condensed matter physics and helped scientists understand quantum fluids more deeply. This discovery is very important. Superconductors can be used in technologies such as MRI machines, high-speed trains, and efficient power transmission. Superfluids help scientists understand quantum behavior on a larger scale. I find this discovery fascinating. It shows that when conditions change, the rules we are familiar with can completely break down. It also teaches us that nature has ideal states where energy loss disappears. In the future, if superconductivity can be achieved at higher temperatures, it may revolutionize energy systems and technology. Even though this topic may seem difficult, it gives us an important message. Limits that seem natural may only exist under certain conditions. Thank you.
Good afternoon, everyone. Today, I would like to talk about the 2003 Nobel Prize in Chemistry. I chose this topic because it shows how life depends on controlling what can enter and leave cells. The prize was awarded for discoveries concerning channels in cell membranes. At first, this may sound complicated, but the idea is quite simple. Every cell in our body is surrounded by a membrane. This membrane acts like a barrier, separating the inside of the cell from the outside environment. However, cells must exchange substances to survive. For example, nutrients need to enter the cell, and waste products must leave. This is where channels play an important role. Channels are special proteins embedded in the cell membrane. They act like gates that allow specific substances to pass through. One key discovery was aquaporins, special channels that allow water molecules to pass through cell membranes efficiently. Others allow charged particles, such as ions, to move in and out. Another was the structural study of ion channels, which showed how cells selectively control charged particles. This process is highly selective. It is similar to a security system. Only certain molecules are allowed to enter, while others are blocked. This discovery was very important. It revealed how cells maintain balance and control their internal environment. It also helped scientists understand how signals are transmitted in the body. I find this discovery very interesting. It shows that life is not just about structure, but also about controlled movement. It also teaches us that systems function properly only when there is a clear rule for what is allowed to pass. In the future, this knowledge may help develop new medical treatments, especially for diseases related to cell function. Even though this topic may seem complex, it gives us an important message. Life depends on selective control, not just open access. Thank you.
Good afternoon, everyone. Today, I would like to talk about the 2003 Nobel Prize in Physiology or Medicine. I chose this topic because it shows how invisible processes inside the human body can be visualized using science. The prize was awarded for the development of magnetic resonance imaging, or MRI. At first, this may sound technical, but the basic idea is quite fascinating. The human body is made mostly of water. Water contains hydrogen atoms, which respond to magnetic fields. In MRI, a strong magnetic field is applied to the body. This causes the hydrogen atoms to align in a certain way. Then a radio signal is sent into the body. When this signal is turned off, the atoms return to their original state and release energy. This released energy can be detected and converted into detailed images. In this way, MRI allows doctors to see inside the body without surgery. This technology is very important. It helps doctors detect tumors, injuries, and other medical conditions. It also provides detailed images of soft tissues, which are difficult to observe using other methods. As a result, doctors can diagnose many diseases more accurately and safely. I find this discovery very impressive. It shows how physical principles can be applied to solve medical problems. It also teaches us that understanding basic science can lead to life-saving technologies. In the future, MRI technology may become even more precise and faster. It may help doctors diagnose diseases at earlier stages and improve patient care. Even though this topic may seem complex, it gives us an important message. Science can transform invisible information into something we can see and understand. Thank you.